Hello everyone, welcome to webinar about sharing point cloud data on Google Maps using TerraScan. I'm Anna Puttonen, software support engineer at Terrasolid. I will use today point cloud example from mobile laser scanning campaign. However, the same steps are relevant for airborne laser scanning data. Today, we will focus tools from TerraScan relevant for publishing point clouds on Google Maps. Today's workflow will include 4 steps. First, we will convert mobile laser scanning project, which is in FBI file format, to LAZ, compressed LAS format to minimize transfer size. This is optional. If you have already your project in LAZ file format, then you don't have to do this first step. Then you can upload your project organized in a smaller regions, in blocks, in any kind of sharing platform. Third step is exporting data to standard format, KML file format, using this TerraScan project. So we will use command export to Google Maps from the menu of defined project window. And in the end, final step, how to import KML file to Google My Maps and to visualize it. Here are project blocks. It's an area of our interest. Example is VT6 road in Finland. On the left side, we see a list of LAZ files. It's a small project example of 6 blocks. And motivation, why do we do this? Because we find it relevant for the users who want to publish 3D content on the web. Our target is to share and communicate 3D information via global maps such as Google. We can access in this way our data from anywhere on the internet. No installation or plugins are needed in this case. It's very easy to use. And in general, it is good to link 3D information with Google Maps because everyone is familiar with it, first of all. So single users, companies, road authorities, municipalities, construction companies, real estate investors, and many others. Above all, it is a popular way to exchange 3D point clouds. Especially nowadays, 3D point clouds are established as the foundation for representation and analysis of objects in numerous disciplines and fields. Therefore, sharing your information easily with others serves for multiple purposes. Now we will switch from presentation to demo. We will be using Trimble MX8 dataset of the road VT6, which you can see here. Road data is collected in a UTM 35 North zone, and processing is done in ETRS Gauss-Krüger 30 plus National High System of Finland, as you can see over here, this information. And we are using source EPSG code 3137 for creating projection change transformation from UTM-35 to ETRS Gauss-Krüger 30, we used TerraScan. In the scan settings, there is a possibility to add here the transformation, because we have to define before we start processing right coordinate system. So now I will open project from my mobile laser scanning project folder. I will use for this demo Spatix platform. This is the way how you can activate Spatix by inviting TerraScan IX app. So here you see it's a small project area of 6 blocks. They are defined along the central line. There are more ways how to define blocks in TerraScan. This is an example for today. I will import one block, but before that I will just rearrange my ribbon. So let's import this first block, and I will change the visualization to be as elevation, for example. So now here you can see we have some fields available on this display. Like this data is already pre-classified. We have line, timestamps, easting, northing, elevation, density information. So you can see here in this table, and which information we store. We can also see in define project window. Under file, edit project information, there is a list of attributes which are saved for this project and available. When you have a final result of your project after matching and classification, and you want to export it in order to publish it on the Google Maps, you don't need to select all of those attributes. So if you want to minimize the file transfer, you can choose the most important ones for publishing. But I'm just showing you what is available as a final result of the project. And as you can see, our project is defined using fast binary file format. So fast binary FBI file format is the best format for processing data in Terrasolid software because it's efficient to read and write the data fast. It is our internal laser point format in Terrasolid. But when we are talking about publishing data, we might choose another file format, as I mentioned in the first step, LAZ, for example. And here, in the project definition, we have a different type of LiDAR which we can choose. So by choosing the mobile LiDAR, this will influence some processing step which are used in TerraScan or TerraMatch. So it's very important that you choose the right one compatible with your project data. So this is now general information about our project. We can start from project main window, from tools to convert storage format. In this case, as you can see, I have 6 FBI files here with this many points per file. So I'm going now to convert them to LAZ1.2, and I won't use all attributes, so some of them I will switch off. So I will leave XYZ class and intensity. I will choose folder where I want to keep LAZ files, LAZ05, for example, in my project folder, and press OK. While blocks are converting, we can just check. So this was size of my files per block. Let's see in total. So 5 gigabytes. Now we'll see after conversion. Six blocks are converted. And now they are listed here. So when we are checking the directory of our project, we have to use now LAZ05. So the project information is changed and saved. So we can see now new size. So it's significantly smaller. And as you can see here, we don't have now some information because we did not include all. So when blocks are converted, we can go to project main window tools and export to Google Maps. So here it's very important to choose right projection. As I said in the beginning, we are processing data in ETRS Gauss Krüger 30. And we can choose here color of our polygons. So we can choose, for example, red. You can select the style of the line and transparency. And now we have here a folder. So this folder is related to our converted blocks. I recommend you to upload this to any sharing platform which you have available. I already did that. Upload sometimes takes time, so I don't want now to use this time of webinar for uploading purposes. So I will show you, I have them over here. So I'm just sharing now the link of this folder. And I'm using it here. So that's an important thing, the storage, where it's going to be uploaded. And after this step, you should give the name for KML file. So we can create it in either in Laser05, or we can just create it over here, where is our mobile laser scanning project folder. So I will call it Finland Road VT6. And now I can use this KML file to import in Google My Maps. So in Google, you can find Google My Maps, where you can create a new map. So here we can give the name of the project, Finland Road VT6, and description MLS LiDAR. There is an import. So this is the place where we import KML file from TerraScan. So this is MLS project folder, and where I saved my KML file. And now you can see blocks in red color. I selected this transparency. So you see that where are we? And we can choose which base map we want to use in background. So we can change it over here. And now we have here name polygons. We can rename this layer, and we will call it laser blocks. So this is the list of 6 blocks. And when you click on one of them, you get the link. So you get this path to block file on your server or on your sharing platform where you have uploaded that block data. If you go right click, you can open it in a new tab, and then you can just download the entire folder, or you can download selected file. So this will download a point cloud file from selected polygon, or just click directly on this link, so as you wish. Each polygon has a link to its own point cloud file. So I will just go through to show you. And this linking and publishing was quite fast and easy. So this was a demo for sharing point clouds from mobile laser scanning platform. If you want to watch video how to handle, for example, airborne data set for entire city, watch this video. It's on Terrasolid YouTube channel, and it shows a bit different block design and how to publish those LiDAR files from airborne laser scanning data for one city in Finland. So I will go back now to my slides. And I want to conclude. We find this publishing and sharing point clouds on Google Maps useful because in this way we make 3D data easily available, enabling an access to presentation of 3D content. Then we are displaying area of interest linked with point cloud files using Google. And we use this value of the location with Google Maps platform. If you want to display more information on Google Maps, such as travel view in point cloud data, and publish travel view as a frame, you can see here an example. So this travel view can be published as a frame. So watch this video on our YouTube channel. It shows how to export views of point cloud and vector data with Terraphoto and Google Maps. And it's also stores the location tag in EXIF metadata file. So any external program supports this and can be used for visualization.